Okay, this is the question prep and walkthrough answers for question 5. Let's go through that from the beginning. So this says the resistor is a component that is used in an electric circuit. The resistor, let's find that here. That is this part. That is the resistor. Okay, there it is. We've got some other components to think about. We've got a switch here. We've got an ammeter here. Over here, we've got a variable resistor. We've got a power supply here. Okay, with our 2 cells makes with that it's a battery or power supply, and we've got here a voltmeter. So we've got a variable resistor, battery, switch, voltmeter, ammeter. Okay, describe the describe how the student will use the circuit to make readings necessary. So use this circuit, make readings necessary to determine the resistance of R. Okay, the resistance of R. Now, okay, we've got V equals IR. I'm going to put that there as an understanding. So I would start off with saying to determine. Okay, we need to use the equation. Oh, no. We use equation V equals I times by R, rearranged to R equals V over I. Okay, that's our first part. So that's the equation we use. Now, this is going to be a 6-mark question, a 6-marker, so when you think about 6 different things. Okay, so we've said that R equals V over I, and then so therefore we need to, number 1, let's think about how we're going to get this circuit to work. We need to switch it on. Switch on. Okay, that's point 1. Point 2, once we've switched it on, okay, we're going to take readings. From ammeter and voltmeter. Okay, so we switched it on using the switch. Then we've used the ammeter and the voltmeter to take readings. Okay. Now it says determine how the student would use that to determine the resistance of R. Now that's good for 1, but let's change. We've got the variable resistor here for a reason, because we're going to take multiple readings. So then number 3, we're going to use variable resistor to change the current. Then number 4, repeat the readings. So we've switched it on, we've taken the readings, we've used the variable resistor to change the current, and then we've repeated that readings. Okay, and then input the readings. Into R equals V over I. That gives you R, and then take an average R result. Okay, that's how you go about doing that question. Next question. Explain why the student should open the switch after each reading. Okay, so why should he? Now this takes us back to our understanding from our resistance through a wire practical, where we had to turn off the power supply between each thing. So, or we could use a switch and turn off the switch. We turn off the switch to reduce heating. But then this is going to be worth more than 1 mark, okay? Because heating increases the resistance and that would affect the results. Because the flow of current produces heat. Okay? So what we need to do, we want to the idea is to reduce the heating effect. Now, and what do we mean by that? So the flow of current produces heat. So if we turn it off, it stops the flow of current, and therefore the heating will decrease. But if we did leave it on, the heating increase would increase the resistance, and that would affect the results. Okay? In an experiment using a circuit, an ammeter of reading 0.75 amps, we calculated the value of resistance of R as 16 ohms. What is the voltmeter reading? Okay, now again, the same as we did before, we need the V equals I times by R. So that's our understanding, that's our Ohm's law. And we want R is 16 and 0.75 is A. So we got R and A. Okay, so V equals 0.75 times by 16, which is 12 volts. Okay, 12 volts. That's 3/4 of 16. Next question. The student told his teacher that the resistance of R was 16 ohms. The teacher explained that the resistors used could only have had the following values: 10, 12, 15, 18 and 22. Suggest which of these resistors the student had used in his experiment and give your answer why. Okay, so let's suggest it's 15, okay, because it's closest to 16. Okay, 15 ohms is close to 16. Okay, but we'd also need to make a point that that 18 would be having a greater resistance, so it wouldn't show a greater resistance. Okay, so he thought it was 15 because it worked it out with the error perhaps on it using his graph, so there was some kind of error introduced. So 15 is the closest to 16, okay, because it's the closest one. 16, 18 is too further away, so we'll say that it must be that one there, 15. Okay, and then last but not least, we've got this fuse. Okay, there's a fuse, it's got a 5 amp fuse in it. Okay, now we can remember what the diagram for a fuse is this resistor, because it is a resistor, with a wire that goes through the middle of it. So we see a resistor with a wire through it, and that's what we call a fuse. Okay, that's a circuit diagram for a fuse. Now, what a fuse does, okay, describe the action of the fuse in a circuit. So, we've got to say that the action of a fuse in a circuit, if I current increases past 5A, current makes the wire inside the fuse get too hot and break. So there's the current flowing through here, the current's flowing into here, through there, out there. So the current comes into this, and the wire's inside there, a thinner wire's inside there. So if the current exceeds 5A, and with this thin wire inside there, that wire is going to get hot enough to break. If it breaks, it breaks the circuit, breaking the circuit. And what that does, that protects any equipment that you might have that would be damaged if the current became larger than 5 amps, or if you left it on and the current became higher than 5 amps, would cause a fire to happen. So that's what we use that for. Okay, and that is the last of the questions.